Hello everyone, welcome to Easy.Life Science, where you will learn science topics easily. In today's lecture, we will learn about bioleaching. Bioleaching is a biotechnological process which uses microorganisms to extract and recover metals from low-grade ores and solid waste and later transforming them into soluble forms. Microorganisms, such as acidophilic bacteria and fungi, produce acids and oxidizing agents that solubilize insoluble metal compounds into a leach liquor, allowing for the metal's recovery. This process is particularly useful for metals like copper, zinc, gold, and uranium, offering a cost-effective and environmentally friendly alternative to conventional chemical methods for processing low-value ores. What are all the microbes involved in bioleaching? The most commonly used microorganisms for bioleaching are Thiobacillus ferruccidens and Thiobacillus thioxidans. Thiobacillus ferruccidens derives the energy for the growth from the oxidation of iron or sulfur in ores. This microorganism oxidizes ferrous ions, Fe2+, to ferric ions, Fe3+, and converts sulfides, thiosulfate, sulfur to sulfate. Thiobacillus thioxidans has similar functions and it grows mostly on sulfur ores or rocks. Sulfolobus acidocaldarius and Sulfolobus bryerlevi are two other bacteria which are involved in bioleaching of copper and molybdenum from ores like chalcopyrite and molybdenite. Mechanisms involved in bioleaching. Usually bioleaching was achieved by two ways: direct action and indirect action. In direct action, bacteria act on the ore directly to extract metal. Whereas in indirect action, the bacteria produces some chemical substance like acids or ions, which lead to extraction of metal from the ores. In mining industry, both the direct and indirect method is used in combination to extract metal economically. Direct bioleaching. In direct bioleaching, minerals which are susceptible to oxidation undergoes direct enzymatic attack by the microorganisms. Certain bacteria such as Thiobacillus ferruccidens oxidize ferrous ions to ferric ions. Indirect bioleaching. In the indirect method of bioleaching of minerals, bacteria produces strong oxidizing agents which react with metals and extract them from the ores. Bacteria produce oxidizing agents such as ferric ions and sulfuric acid on oxidation of soluble iron and soluble sulfur respectively. Commercial process of bioleaching. 1. Slope leaching. In slope leaching, the ores is finely ground and kept in large pile in a slope, which is subjected to continuous sprinkling of aqueous solution of microorganisms. The leach liquor collected at the bottom of the ores is processed further for metal recovery. 2. Insitu leaching. In insitu leaching, the ores is subjected to bioleaching in its natural occurrence. Aqueous solution of microorganism is pumped through the drilled passages within the ores. The leach liquor was collected at the bottom of the ores, which is then used for metal extraction. 3. Heap leaching. In heap leaching, the ores is arranged in heap and goes through the same treatment such as in slope leaching. The aqueous solution containing microorganisms works on the heap of ores and produces the leach liquor. The leach liquor is used for metal recovery. In all these three processes of commercial bioleaching, the aqueous solution of microorganisms can be reused. Advantages of bioleaching. Since bioleaching employs microorganisms for metal recovery, it possesses several advantages over the other conventional methods, which use mainly chemicals. Through bioleaching, extraction of metals from low-grade ores is possible. It is very economical process compared to other processes employed for collecting metals from wastes or drainages. Since it uses living microbes, it is environmental friendly process. This method is also used to extract refined and expensive metals, which is not possible by other chemical processes.